A dark world from nowhere. For billions of years, our solar system has lived inside a fragile order. The sun burns at the center. Mercury races close to its fire. Venus glows beneath thick clouds. Earth moves quietly through the habitable zone. Mars circles as a cold, red world. And beyond them, giant planets guard the outer darkness. Jupiter, Saturn, Uranus, Neptune. Everything appears stable. Everything appears ancient. Everything appears safe. But space is not empty. And the darkness between stars is not dead. Love space, science, and cosmic mysteries. Subscribe to the Cosmic Earth and join this journey into the hidden dangers of our universe. Far beyond Neptune, far beyond Pluto, far beyond the frozen edge of the solar system. There may be worlds wandering alone, no sunrise, no sunset, no parent star, no warm light falling across their frozen surfaces, only darkness. These are rogue planets, worlds without a home. A rogue planet is not science fiction. Astronomers believe planets can be thrown out of their original star systems by gravitational chaos. In the early life of a solar system, planets do not always form peacefully. Young stars are surrounded by disks of gas, dust, rock, and ice. Inside those disks, planets begin to grow. Some become small rocky worlds. Some become giant gas planets, some settle into stable orbits, but some are not so lucky. When massive planets move close to each other, their gravity can change everything. One planet can pull another into a new orbit. A giant world can push a smaller planet outward. Two planets can pass too close and create a gravitational slingshot. And in the most extreme cases, a planet can be thrown completely out of its solar system. From that moment on, it becomes a wanderer. It does not orbit a star anymore. It drifts through interstellar space, silent, cold, almost invisible. A planet like this could travel for millions of years, maybe billions. It could pass through the darkness between stars without ever being seen. No one lives under its sky. No oceans reflect starlight, no seasons pass, no day ever comes. It is a world separated from light. And now imagine one of these worlds heading toward us. At first, no one notices. The solar system continues as usual. Earth spins, the moon rises, the oceans move under gravity. Cities glow through the night. People look at the sky and see the same stars their ancestors saw. But somewhere beyond the known planets, in the cold borderlands of the solar system, a faint object appears in telescope data. Not bright, not dramatic, not terrifying, just a tiny point moving against the background stars. At first, it looks like another distant object, maybe a comet, maybe a dwarf planet, maybe an icy body far beyond Neptune. Astronomers mark its position. They compare images taken on different nights. They measure its motion, and slowly the numbers begin to look strange. This object is not moving like a normal solar system body. Its path does not match the slow orbit of a distant dwarf planet. It does not behave like a typical comet falling inward from the outer solar system. Its speed is different. Its direction is different. Its trajectory seems to come from deep interstellar space. A visitor, not born here, not bound to the sun. At first, scientists remain careful. One observation is not enough. A few nights of data can be misleading. Distance can be misjudged. Speed can be uncertain. A small error can change the entire prediction. So more telescopes turn toward it. Observatories across Earth begin tracking the object. Space telescopes search for infrared heat. Computers calculate its path again and again. And with every new measurement, the answer becomes harder to ignore. This is not an asteroid. This is not a comet. This is not a small icy rock. It is massive, far more massive than anything expected to enter the solar system. maybe smaller than Neptune, maybe larger than Earth, maybe a frozen super-Earth thrown out of another star system long ago. A planet, a rogue planet. The discovery would change the world overnight. News would spread slowly at first. A strange object beyond Neptune, an unusual interstellar body, a possible planetary mass visitor. Then the headlines would become darker. A rogue planet may enter the solar system. Scientists are tracking a massive object from deep space. A wandering world is approaching the sun. But even then, many people would not understand the danger. Because in our imagination, cosmic disasters usually mean collision. An asteroid hitting Earth, a comet striking the ocean, a planet crashing directly into us. But a rogue planet does not need to hit Earth to become dangerous. Its weapon is gravity, and gravity does not need contact. Gravity reaches across space. It pulls silently. It bends orbits. It changes paths. It disturbs objects long before anything visibly happens. A rogue planet entering the solar system would not arrive like an explosion. It would arrive like a slow, invisible pressure. At first, the danger would exist only inside calculations. Tiny changes in predicted positions. Small differences between where objects should be and where they actually are. A comet slightly displaced, a distant icy body moving differently, a planet's orbit showing a tiny variation. To most people, nothing would look wrong. The sun would still rise, the stars would still shine, the seasons would still continue. But inside observatories, something terrifying would be happening. The solar system's perfect clockwork would begin to lose certainty. For centuries, humans have learned to predict the motion of planets with incredible accuracy. We know when eclipses will happen. We know where Mars will appear. We can send spacecraft across millions of kilometers and arrive near distant planets. This precision exists because the solar system is stable, not perfectly frozen, not completely unchanging, but stable enough for mathematics to guide us. A rogue planet would threaten that stability. If it passed far away, the solar system might survive, almost untouched. If it passed closer, it could disturb the outer planets. If it passed through the region beyond Neptune, it could throw comets inward. If it came near Jupiter or Saturn, the consequences could become unpredictable. And if it came too close to Earth's orbit, then humanity would face something it has never faced before. Not a storm, not an earthquake, not a war, not even a single asteroid, but a gravitational event on the scale of the entire solar system. The strangest part is that the rogue planet might not even look impressive at first. It would not shine like a star. It would not burn with its own light. It might be covered in ice, rock, or a thick frozen atmosphere. From far away, it would be almost invisible except for the faint sunlight reflecting from its surface or the weak heat left inside it. A dark world coming from the dark, a shadow moving through a system built around light. And as it moved closer, scientists would try to answer the one question that mattered most. Where is it going? The first predictions might bring relief. Maybe it will pass far beyond Neptune. Maybe it will only disturb distant objects. Maybe Earth is safe. But then more data arrives. The path changes slightly, not because the planet changed direction suddenly, but because humans understood its direction better. Every new observation sharpens the danger. The uncertainty region becomes smaller. The future becomes clearer. And the clearer it becomes, the more frightening it looks. The rogue planet is not just passing near the solar system, it is entering it, crossing the outer boundary, moving into the sun's gravitational kingdom. For the first time in human history, a planet from another star system is coming into our cosmic home, and Earth can do nothing to stop it. We could not push it away. We could not destroy it. We could not change its path with rockets. A planet is not an asteroid. It is not a mountain of rock. It is a world. Its mass could be greater than Earth. Its gravity could reshape the paths of smaller bodies around it. Against something that large, human technology would be almost meaningless. All we could do is watch, measure, calculate, prepare, and hope that gravity does not choose Earth. As the rogue planet moves inward, the first real effects would not happen on Earth. They would happen far away, in the cold outer regions where sunlight is weak and ancient objects sleep in darkness. The Kuiper Belt, the scattered disk, the frozen remnants left over from the birth of the solar system. For billions of years, many of these bodies have remained quiet. But the arrival of a rogue planet could wake them. Its gravity could pull some inward, push others outward, break old orbital patterns, turn harmless frozen worlds into future threats. And this is where the true fear begins. Because the rogue planet itself may not be the first thing to threaten Earth. The first warning may come from smaller bodies, objects that were disturbed, objects that were redirected, objects that begin falling toward the inner solar system. Long before the rogue planet becomes visible in the night sky, the sky may begin to change. New comets may appear. More streaks of light may cross the atmosphere. Astronomers may detect objects moving toward the planets on paths they have never seen before. At that moment, humanity would understand something terrifying. The rogue planet is not alone. It is carrying chaos ahead of it, not by intention, not like an enemy, but by gravity. A silent force spreading through the solar system before the dark world fully arrives. And from Earth, we would still stand under the same sky, not knowing whether we are witnessing a rare cosmic visitor or the beginning of the end of the solar system we have always known. The solar system begins to tremble. At first, the rogue planet is still far away, far beyond the warm light of the inner planets, far beyond Mars, far beyond Jupiter and Saturn, far beyond the familiar worlds that humans have studied for centuries. It is moving through the cold, outer darkness, where sunlight is weak and the solar system no longer feels like a bright, organized place. Here, the sun is not a blazing disk in the sky. It is only a distant star, a bright point surrounded by blackness. This is the outer solar system, a region of ice, silence, ancient debris, and forgotten worlds. For billions of years, this distant kingdom has remained mostly undisturbed. Beyond Neptune lies the Kuiper Belt, a vast ring of icy bodies left over from the birth of the solar system. Pluto lives here. So do other dwarf planets, Eris, Haumea, Makemake, Quaoar, Orcus, small frozen worlds moving slowly through the dark. They are not dead objects. They are memories, pieces of the early solar system, fragments from the time when planets were still forming. Most of them never became full planets. They remained small, cold, distant, locked in ancient orbits. But now something new has entered their kingdom. A planet that does not belong here. A world from interstellar darkness. The rogue planet does not need to crash into anything. It does not need fire. It does not need speed like a bullet. Its gravity is enough. Gravity is invisible, but it is never silent. Every object in space pulls on every other object. The sun pulls the planets pull the sun. Jupiter pulls asteroids. Neptune shapes the Kuiper Belt. Even Earth pulls on the moon and raises tides in the oceans. This is the hidden architecture of the solar system. Not walls, not roads, not metal tracks. only gravity, a delicate balance of motion and attraction. For billions of years, that balance has kept the planets moving in their paths. But when a massive outsider enters this system, the balance begins to change. At first, the changes are tiny, so small that no human eye could see them. A distant, icy object moves slightly faster than expected. Another one shifts a little from its predicted path. A comet that should have stayed far away begins to fall inward. The first signs are not explosions, they are errors, numbers that no longer match, predictions that begin to fail. Astronomers notice that some outer solar system bodies are being disturbed. Their orbits are not breaking completely yet, but they are changing. And in space, small changes can become enormous with time. A slight pull today can become a dangerous path tomorrow. A frozen body that once moved safely beyond Neptune may begin a long fall toward the Sun. Another may be thrown outward forever, escaping into interstellar space. Another may cross the orbit of Neptune, then Uranus, then Saturn, then Jupiter. The solar system is not simply a collection of separate worlds, it is connected. A disturbance in the outer region can travel inward through gravity, like a ripple crossing a dark ocean. The rogue planet moves closer. Slowly, its influence grows. The Kuiper Belt begins to lose its ancient calm. Objects that slept for billions of years are awakened. Some are pulled into stretched, unstable orbits. Some begin drifting into the scattered disk, a region where bodies already follow strange, elongated paths. Some are pushed toward the inner solar system, and this is where the danger becomes real. Because the rogue planet itself is not the only threat, it can create thousands of smaller threats: comets, icy fragments, rocky bodies, dark objects that reflect almost no light. Objects that were once harmless because they stayed far away. Now their paths are changing. Some of them begin falling toward the Sun. As they approach the inner solar system, sunlight warms their frozen surfaces. Ice begins to vaporize, dust escapes, long glowing tails appear. From Earth, people begin to see more comets in the night sky. At first, it looks beautiful, a rare celestial event. A bright visitor above the horizon, then another appears, then another. Astronomers begin to understand that this is not normal. The sky is becoming active, too active. Comets are arriving from unusual directions. Their paths do not match ordinary patterns. Some seem to have been pushed inward recently. Some pass near the orbits of giant planets. Some cross dangerous regions near Earth. The public watches the sky with wonder. Scientists watch it with fear. Because every comet is a clue. Every new object is a message from the outer darkness. The rogue planet is disturbing the solar system before it has even reached the planetary region. And the closer it comes, the stronger the disturbance becomes. Neptune may be the first major planet to feel the outsider's pull. Neptune is massive. Its gravity helps shape the outer solar system. It controls many objects beyond its orbit through gravitational resonance. But even Neptune is not immune to a passing planet. If the rogue planet passes far from Neptune, the effect may be small, but if it passes close enough, Neptune's orbit could shift slightly. Not a dramatic change visible in the sky, not a sudden fall, but a tiny change in speed, a tiny change in direction, a tiny change in gravitational balance. And in orbital mechanics, tiny changes matter. A planet does not need to move much to disturb everything around it. Neptune's movement could alter the paths of objects trapped near it. The Kuiper Belt could become more unstable. Distant bodies could be scattered. Some could be thrown outward, others inward. The outer solar system would begin to behave like a shaken field of ice and stone. Uranus could also be affected if the rogue planet continues inward. Its orbit may not break, it may not be thrown away, but the gravitational relationship between Uranus and Neptune could change. Even small shifts could create long-term instability. The solar system is old because its architecture has remained balanced for a very long time. But a rogue planet is a new mass added to an old equation. The planets are no longer moving only under the familiar influence of the Sun and each other. A stranger has entered the calculation, and the calculation becomes more uncertain with every passing year. On Earth, space agencies begin working together. Telescopes scan the sky constantly. Old data is rechecked. New simulations are created. Supercomputers run millions of possible futures. In some futures, the rogue planet passes through the outer solar system and leaves. Damage is limited. The planets survive. Some comets are disturbed, but Earth remains safe. In other futures, the rogue planet passes closer. The outer planets shift. The Kuiper Belt becomes unstable. The scattered disk sends icy bodies inward for thousands or even millions of years. And in the worst futures, the rogue planet does not simply pass through the edge, it moves deeper, toward the giant planets, toward the gravitational heart of solar system chaos. Jupiter and Saturn. These two worlds are not just planets, they are giants. Their gravity dominates much of the solar system. Jupiter alone is more massive than all the other planets combined. It can capture objects, deflect them, throw them inward, throw them outward, protect Earth from some impacts, and send other objects into dangerous paths. Saturn also plays a powerful role. Together, Jupiter and Saturn help shape the asteroid belt, comet paths, and the long-term stability of planetary orbits. If the rogue planet reaches their region, the situation changes completely. This is no longer just a distant disturbance. This becomes a gravitational encounter between worlds. A giant outsider passing near giant planets that already control millions of smaller bodies. The solar system becomes a machine with one extra gear forced into its center. No one can predict every result with perfect certainty, because gravity is simple in principle, but chaotic in large systems. 2 bodies can be calculated, 3 bodies become complicated. Add planets, moons, asteroids, comets, dwarf planets, and a massive rogue world. And the future becomes a storm of possibilities. On Earth, people begin to feel the fear in a new way. Not because anything has hit the planet, not because oceans have risen, not because the ground is shaking, but because certainty is disappearing. The future sky can no longer be predicted the way it once was. A comet that was safe in one simulation becomes dangerous in another. An asteroid belt object shifts into a possible Earth-crossing path. A distant icy body appears where it should not be. The universe has not attacked Earth directly. It has attacked prediction, and prediction is one of humanity's greatest defenses. If we know an asteroid is coming years in advance, we may have a chance. If we know a comet's path, we can prepare. If we know the motion of planets, we can send spacecraft, plan missions, and understand risk. But when the solar system becomes chaotic, knowledge becomes weaker. Every new observation changes the future. Every updated calculation brings a different possibility, and all of it began with one dark world entering from nowhere. The rogue planet continues moving inward. Behind it, the outer solar system is no longer quiet. Some objects have been thrown away forever. Some are falling toward the sun, some are crossing planetary paths, and some are still too dark to see. That may be the most frightening part. For every bright comet that appears in the sky, there may be darker bodies moving unseen. Rocky objects, frozen fragments, ancient debris with almost no reflective surface. They do not glow until they are close. They do not warn us early. They travel through darkness, carrying the gravitational signature of the rogue planet's passage. The first visible comets were only the beginning. Now, the inner solar system is waiting. Mercury, Venus, Earth, Mars, the warm region where life exists, the fragile zone where civilization was built, and far away, the dark planet keeps coming. Not fast enough to look sudden, not slow enough to feel safe. A world without a star is entering a system built around one, and every orbit it touches becomes a little less certain. The solar system is beginning to tremble, not with sound, not with light, but with gravity. And gravity does not announce disaster. It simply changes the path. Earth under a changing sky. For most people on Earth, the beginning of the disaster would not feel like a disaster. The oceans would still move. The winds would still cross continents. The sun would still rise over cities, forests, deserts, and mountains. Children would still walk to school. Airplanes would still cross the sky. Farmers would still watch the weather. Ships would still move across dark oceans beneath the moon. Life would continue with frightening normality. Because the first signs of cosmic danger do not always appear as fire in the sky. Sometimes they appear as numbers, tiny differences, small orbital errors, predictions that no longer fit reality. At observatories around the world, astronomers would begin noticing something disturbing. Objects in the inner solar system are not exactly where they should be. Mars is still Mars, Venus is still Venus, Earth is still moving around the Sun. Nothing looks broken, but the calculations are changing. A comet that should have passed safely beyond Mars is now moving slightly closer. An asteroid that once had a stable orbit now shows a small uncertainty. A near-Earth object appears earlier than predicted. Another appears from a direction no one expected. At first, these differences seem technical, scientific, distant. But behind every number is a terrifying truth. The solar system is no longer behaving like the solar system humanity knew. The rogue planet is still far away from Earth, but gravity does not wait for arrival. Gravity reaches ahead. It pulls across distance. It quietly changes motion. And now that invisible force is beginning to touch the region where life exists. Earth is not fixed in space. It never has been. Our planet is not standing still beneath the sun. It is falling around the sun at nearly 30 kilometers every second. Always moving, always balancing, always held in place by a perfect relationship between speed and gravity. If Earth moved too slowly, it would fall inward. If Earth moved too fast, it would drift outward. Our entire world exists inside that balance. The warmth of our climate, the rhythm of our seasons, the stability of oceans, the growth of forests, the rise of agriculture, the building of civilization, all of it depends on Earth staying in the right orbit. And now, for the first time in human history, that orbit is no longer a simple certainty. The rogue planet does not need to come close enough to touch Earth. It does not need to block the sun. It does not need to crash into the moon. A small gravitational change could be enough to alter the future. If Earth's orbit became slightly more stretched, seasons could become more extreme. Summers could grow hotter. Winters could become longer and harsher. Some regions could face drought. Others could face floods. Ice sheets could begin changing. Ocean currents could shift. Weather patterns that supported human life for thousands of years could become unstable. And the most frightening part is that these changes might not happen instantly. They could unfold slowly, year after year, decade after decade, a disaster too large to feel at first, but too powerful to escape. For ordinary people, the first visible sign might be the sky, not one comet, many. Bright tails appearing where the sky was once empty. Meteor showers becoming stronger, news reports showing new objects crossing near Earth's orbit. Scientists explaining probabilities, governments holding emergency briefings, social media filling with fear, denial, theories, and panic. Some people would look up in wonder, others would refuse to look at all, because the sky, which once felt peaceful, would begin to feel alive. And not alive in a comforting way, alive like something ancient had been disturbed. The moon would still rise, but above it, new streaks of light might appear. The stars would still shine, but between them unfamiliar visitors would move. Comets shaken loose from the outer darkness would begin entering the inner solar system. Some would pass far away. Some would break apart near the sun. Some would cross the paths of planets, most would miss Earth, but most is not enough when millions of lives depend on the word all. Humanity has planetary defense systems, telescopes, radar, space agencies, mathematical models, possible asteroid deflection missions. But those systems are built around prediction. They depend on early warning. They depend on knowing the object, its speed, its path, and its mass. A rogue planet changes the environment around those objects. It makes the solar system more crowded, more uncertain, more dangerous. It turns the sky into a moving field of possibilities, and Earth sits inside that field, a blue planet wrapped in a thin atmosphere, a living world protected not by walls, but by distance, luck, and gravity. Inside control rooms, scientists would work without sleep. They would compare old star charts with new images. They would track every incoming object. They would update impact risks again and again. One day, a comet might have a 1 in a million chance of hitting Earth. The next week, after new observations, the risk might fall. Then another object appears, then another, then another. The fear would not come from one confirmed impact. It would come from the endless uncertainty. A civilization can prepare for a single enemy. It is much harder to prepare for a changing sky. Meanwhile, the rogue planet continues inward, still dark, still distant, still mostly invisible to human eyes. But its presence is now felt everywhere in the calculations. Astronomers begin studying its possible effect on Earth's orbit. They ask questions humanity has never had to ask in modern history. Could Earth be pulled slightly closer to the Sun? Could it be pushed slightly farther away? Could its orbital shape change? Could the Moon's orbit be affected? Could tides become stronger? Could the length of the year shift? Could the climate system become unstable? Most scenarios do not destroy Earth immediately. That is what makes the situation feel more real. The planet does not explode, the oceans do not instantly boil, the atmosphere does not vanish in one day. Instead, Earth becomes uncertain. And uncertainty is terrifying when the entire human future depends on stability. Imagine a world where seasons no longer follow their old rhythm, where monsoons shift, where harvests fail in places that once fed millions, where coastlines face stronger storms, where extreme heat and deep cold become more common, where governments prepare not just for disaster relief, but for planetary adaptation. This is the hidden danger of a rogue planet. It may not end life with one dramatic impact. It may injure the system that keeps life stable. Earth's orbit is like the heartbeat of civilization, regular, predictable, trusted. But if that heartbeat changes, everything built upon it begins to shake. And still, the public would ask the simplest question: will it hit us? Scientists might answer carefully: no direct collision is currently predicted, but that answer would not bring peace, because the danger is larger than collision. The rogue planet could pass far from Earth and still change the paths of objects around us. It could disturb asteroids. It could alter comet streams. It could slightly reshape Earth's orbit. It could interact with giant planets and create long-term chaos that lasts far beyond the first passage. The event would not be a moment, it would be an era, a before and after in the history of the solar system. Every night, more people would look upward. The sky would become the center of human attention again, not because of beauty, but because of fear. For thousands of years, humans looked at the heavens and saw gods, omens, stories, and destiny. Then science taught us to see planets, stars, galaxies, and laws of physics. But now, under a changing sky, something ancient would return: the feeling that the heavens can decide the fate of Earth. The rogue planet would remind humanity of a truth we often forget. We do not live separate from space, we live inside it. Earth is not below the universe, Earth is part of the universe, a moving world among moving worlds, a small blue body traveling through a gravitational ocean. And when that ocean is disturbed, even Earth can feel the wave. As the rogue planet approaches the region of the giant planets, every simulation becomes more tense, because beyond Mars lies Jupiter, the largest planet in the solar system, a world so massive that its gravity has shaped the history of asteroids, comets, and planets for billions of years. Jupiter has protected Earth from some dangers, but it has also redirected objects into dangerous paths. It is both shield and weapon, guardian and chaos engine. And now the rogue planet's path may bring it near Jupiter's domain. If that happens, the danger will no longer be limited to distant comets and uncertain calculations. The two gravitational giants could interact. Their pull could reshape paths across the solar system. Asteroids could be thrown inward. Comets could be redirected. Planetary orbits could shift in ways no one can fully control. Earth would not just be watching a rogue planet anymore. Earth would be watching the giant planets become part of the disaster. And under that changing sky, humanity would realize something terrifying. The rogue planet is not only approaching the solar system, it is approaching the forces that hold the solar system together. The giant planets become weapons beyond Mars. The solar system changes character. The small rocky worlds end, and the kingdom of giants begins. Here, space is ruled by planets so massive that their gravity does not simply hold moons. It shapes the motion of millions of objects: Jupiter, Saturn, Uranus, Neptune. These are not quiet worlds floating peacefully in the dark. They are gravitational engines. For billions of years, they have shaped the architecture of the solar system. They have pulled comets, captured moons, scattered asteroids, redirected ancient debris, and in many ways they help decide what kind of solar system Earth would live in. Jupiter especially is a giant unlike anything near Earth. It is more massive than all the other planets combined. Its gravity is so powerful that it can bend the paths of objects passing millions of kilometers away. Sometimes Jupiter protects Earth by pulling dangerous objects away. Sometimes it sends objects inward, toward the Sun, toward Mars, toward Earth. It is both shield and threat, a guardian and a weapon. And now the rogue planet is approaching this dangerous region. This is the moment scientists feared most, because a rogue planet passing through the outer solar system is terrifying. But a rogue planet passing near Jupiter is something else entirely. It is no longer just an outsider disturbing frozen debris. It becomes a gravitational encounter between worlds, a massive stranger entering the territory of the solar system's largest planet. The calculations become more unstable. The simulations become more frightening. In one possible future, the rogue planet passes far enough from Jupiter that the system survives with limited damage. Some comets are disturbed, some asteroid paths change, but the planets remain mostly safe. In another future, the rogue planet passes closer, too close, not close enough to collide, but close enough for gravity to begin rewriting motion. Jupiter pulls on the rogue planet. The rogue planet pulls on Jupiter. For a short time, two massive worlds grip each other across space. No sound, no fire, no visible explosion, only gravity. But that invisible pull may be stronger than any explosion humanity has ever imagined. A tiny change in Jupiter's speed could ripple across the solar system. A small shift in its orbit could disturb the asteroid belt. Its moons could feel altered tides. Objects trapped by Jupiter's gravity could be thrown into new paths. Some could be flung outward into deep space. Others could be launched inward, toward the region of the rocky planets, and this is where the disaster becomes larger than the rogue planet itself. Because Jupiter does not move alone, Jupiter is connected to Saturn. Saturn is connected to the asteroid belt through gravitational resonances. The asteroid belt is connected to Mars and Earth through crossing orbits. The solar system is not a set of separate islands. It is one gravitational web. Pull one thread hard enough, and the entire web begins to shake. The asteroid belt becomes one of the first inner regions to suffer. Between Mars and Jupiter, millions of rocky bodies orbit the Sun. Most are small, some are mountain-sized, some are large enough to destroy regions of Earth if they ever struck. For billions of years, many of them have stayed in relatively stable paths. But Jupiter has always influenced them. There are gaps in the asteroid belt where Jupiter's gravity has already cleared objects away. There are regions where orbital resonance can slowly push asteroids into dangerous paths. Under normal conditions, this process is slow. But the rogue planet changes the conditions. If Jupiter's gravitational rhythm is altered even slightly, the asteroid belt could become more unstable. Objects that once stayed safely between Mars and Jupiter may begin drifting inward. A few may cross Mars. Some may approach Earth's orbit. Others may be pulled into chaotic paths that no one can predict far in advance. Now the sky is no longer just filled with comets from the outer darkness. It is also threatened by rocky fragments from within the solar system itself, ancient stones, metal-rich bodies, dark asteroids, pieces of a planet that never formed. And each one becomes a question. Where will it go? Will it miss Earth? Will it hit the moon? Will it break apart near the sun? Will it return decades later on a more dangerous path? Humanity's telescopes work constantly. Radar stations track near-Earth objects. Space agencies share data. Governments hold emergency meetings. Scientists build new simulations every day. But the problem is no longer one object. It is a changing system. A single asteroid can be tracked. A single comet can be studied. A single impact risk can be planned for. But what happens when thousands of objects begin shifting? What happens when the source of the danger is not one rock, but the gravitational disturbance of the solar system itself? The rogue planet continues moving through the giant planet region. Saturn now becomes part of the story. With its rings shining like a delicate crown, Saturn appears beautiful from far away. But Saturn is also a massive gravitational force. Its relationship with Jupiter helps shape the long-term stability of the solar system. If the rogue planet disturbs Saturn's orbit even slightly, the results could unfold over centuries. That is the strange terror of this event. Some disasters would happen quickly, a comet appearing suddenly, an asteroid passing too close, a meteor shower becoming violent, but other consequences would be delayed. The solar system might continue changing long after the rogue planet has moved away. A path altered today could become an impact threat hundreds of years later. A comet disturbed now might not enter the inner solar system for thousands of years. A planet's orbit might remain safe at first, then slowly drift into a new pattern. The rogue planet would not just create a crisis, it could create a new era of uncertainty, and Earth would be living inside it. On the ground, people begin to understand that this is not a normal disaster. There is no single landfall, no epicenter, no storm path, no border between safe and unsafe. Every nation is under the same sky, every ocean reflects the same moon, every city depends on the same orbital stability. For once, humanity faces a danger that does not belong to one country, it belongs to the planet. But even united, humans cannot control a rogue planet. We could send spacecraft to study it, we could measure its mass, we could map its surface, we could predict its path as accurately as possible, but we could not stop it. If it is Earth-sized, its mass is too great. If it is larger than Earth, the challenge becomes unimaginable. If it is a frozen super-Earth or a gas giant thrown from another star system, then human technology is not even close. Rockets cannot push a world away. Nuclear weapons cannot destroy a planet. A rogue planet is not an enemy to defeat, it is a cosmic event to survive. As it passes near the giant planets, the night sky begins to feel different. Some comets become bright enough to see without telescopes, meteor activity increases, news channels show maps of incoming objects. Scientists explain that most will miss, most will burn up, most will pass safely. But fear does not listen to most, because everyone understands that Earth only needs one large impact to change history. Mars may become the first visible warning. A newly redirected object strikes its surface. A flash appears in telescope data. Dust rises from the red planet. A fresh crater forms. No civilization is there to die. No oceans boil. No cities fall. But the message is clear. The inner solar system is no longer untouched. Then the moon is hit. A bright impact flash appears on its dark side. For a moment, people on Earth look up and see proof that the danger is real. The moon, our closest companion, has been struck by debris from the disturbed sky. And if the moon can be hit, Earth can be hit. At the same time, Earth's own orbit becomes a focus of fear. Scientists compare measurements with older records. They look for any tiny change in the planet's path around the Sun. The results are not simple. Earth has not been thrown away. It has not fallen toward the Sun. It still lives inside the habitable zone, but small changes are possible. A slightly altered orbit, a slightly different seasonal rhythm, a slightly changed relationship with the moon. Nothing dramatic enough to end the world in one day, but enough to make the future feel unstable. And that instability becomes the true horror. Because civilization was built during a rare period of climate balance. For thousands of years, humans learned the seasons. They planted crops, built cities, stored water, measured time, created calendars, trusted the sky. But now the sky is changing. Not because the sun has changed, not because Earth has chosen a new path, but because a dark planet from another star system has entered our gravitational home. The rogue planet reaches its closest approach. This is the peak of the crisis. Across Earth, people gather outside. Not because they can stop anything, but because humans have always looked upward when history becomes larger than themselves. In some places, the rogue planet may appear as a faint, dark disk against the background stars. In others, only telescopes can reveal it. It does not glow like a second sun. It does not arrive with flames. It is colder than imagination, a shadow world passing through the realm of light. Scientists watch its movement second by second. Every observatory is pointed toward it. Every calculation is updated. Every possible interaction is studied. And then, slowly, the rogue planet begins to move away from Jupiter's region. It has not collided with Earth. It has not swallowed the moon. It has not destroyed the sun. But no one celebrates too early, because everyone now understands the truth. The danger was never only the rogue planet. The danger was what it changed. Behind it, the solar system is no longer the same perfect clock humanity once trusted. Comets are still moving inward. Asteroids are still being tracked. Jupiter's influence has shifted objects into new paths. Saturn's region may still carry long-term disturbances. The outer solar system has been shaken. The asteroid belt has been stirred, and Earth, though still alive, is now watching a future filled with uncertain skies. The rogue planet did not need to hit us. It only needed to pass through. It only needed to touch the solar system with gravity. And now the question facing humanity is no longer whether the dark world will arrive. It has arrived. It has changed the dance. And Earth must live with whatever gravity has left behind.